Now this is one very interesting problem in statistical probability, and the question is, if we have n tickets which are numbered from 1 to n, then we draw out m tickets. We have to find variance of sum of numbers on these tickets. So we have n tickets which are numbered from 1 to n, and from these n tickets we have drawn n tickets where obviously m is less than or equal to n. Now we need to find variance of sum of numbers on these tickets. Now way to go about it is, we'll assume that let xi be the number on ith draw. And here we are selecting these numbers without replacement. Now we need to find variance of some of these numbers on tickets. So what we'll do is, we'll define a random variable x, which actually is sum of x1 plus x2 plus xn. So we'll simply write this summation I varies from 1 to m xn, and we have to find variance of this random variable x. Now if we talk about this xith draw, what could be the number on this draw? It could be any number from 1 to n. So if we write its uniform probability distribution, we can write probability that this xi, it is equal to k, will be equal to 1 by n if k is from 1 to n and it is 0 otherwise. So the probability that on the ith draw number is k, it is 1 by n. Now if we find expectation of xi, then expectation of xi will be this summation. Now k into p xi equals to k, where k varies from 1 to n. Now this probability is 1 by n, so it will be this 1 by n, and then this summation k varies from 1 to n, summation k, which is n plus 1 by 2. So it will be n plus 1 by 2n. So expectation that ith draw is xi, it is n plus 1 by 2. Now for this random variable x, we can find its expectation using linearity of expectation. So we can write expectation of x as expectation of x1 plus x2 plus xn, which we can also write summation expectation of xi, where I varies from 1 to m. Now expectation of xi is n plus 1 by 2, so it will be simply m into n plus 1 by 2, and that's our first result. Now we have to find variance of this x. Now we know that variance of x is expectation of x square minus expectation x whole square. So here we have to find this term expectation of x square. So what we are looking at is expectation of x square. And what is x square? X square is this x1 plus x2 plus xn into x1 plus x2 plus xn. So basically we can also write this as, this is summation I varies from 1 to m, summation j varies from 1 to m, expectation of xi into xj, basically expectation of this product. We'll get this as x1 square plus x2 square plus xm square, and then 2 times then all these products xi into xj, where I is less than j, where j is less than equal to m, and I is less than equal to 1. So we can write this as this summation I varies from 1 to m, and then we'll have x1 square, x2 square, and xm square. So it will be this expectation of xi square plus 2 times this double summation I is less than j is less than equal to m, expectation of xi into xj. Now in order to calculate ex square, we have to find these two expressions. Now the first one is simple. If we look at this first one, which is summation I varies from 1 to m expectation of xi square. For this, we'll first calculate expectation of xi square. Now it will be this summation I varies from 1 to n, and then what are the possible values of xi square? 1 square, 2 square up to n square. So it will be this I square, and probability of getting 1 square, 2 square and n square, it is 1 by n each. So it will be this 1 by n. So we can write this as 1 by n into n plus 1, 2n plus 1 by 6. Now this n and n will cancel. So it will be this n plus 1, 2n plus 1 by 6. So if we write this, we write this as this summation I varies from 1 to n plus 1, 2n plus 1 by 6. Now essentially this is independent of I. So we can simply write this as n plus 1, 2n plus 1 whole divided by 6. So that's your expectation of xi square. Now we have to calculate this 2 times double summation expectation of xi into xj. So for the second term, we'll find 2 times this summation. One is less than equal to I is less than j. It is less than equal to m e xi into xj. Now the obvious question is, how do we calculate this? And for that, first we look into expectation of xi into xj, which is expectation of product of numbers which occurred at ith and jth position. Now if we look at ith position and jth position, how many products can be formed if I is unequal to j? Now we have total n numbers, and from these n numbers we can choose 2 numbers in nc 2 ways. So the total number of combinations which are possible for xi into xj is nc2, and since each product is equally likely to come, this required probability xi equals some number a and xj equals some number b, it is equal to 1 upon nc2, where a and b, they belong to this set from 1 to up to n, and additional condition is this a is unequal to b. Now if we look at expectation of xi into xj, it will simply be this product AB and then this probability nc2, where both A and B, they lie between 1 and n, and where A is unequal to B. So for the sake of simplicity, rather than changing the variables to A and B, we'll simply write this as this summation I and j, they lie between 1 and n, where I is unequal to j, and will be this I into j upon nc2. And also, how many such pairs will be there for this combination from 1 to n? So for these m numbers, total number of such combinations will be simply mc2. So we can simply write this as mc2 upon nc2 summation I and j varies from 1 to n, where I is unequal to j, I into j. Now we need to find this summation. Now we can simplify this as m minus 1 upon n minus 1. And here it is product of all the numbers from 1 to n except when they're equal. So if we look at this product, 1 plus 2 plus 3 up to n into 1 plus 2 plus 3 up to n. From this, we have removed all those numbers where a number is multiplied by itself. So what we'll do is, we can actually write this as this summation ij, where ij lying between 1 and n minus summation I square. So from this, we have taken out all those cases where I is equal to j. So it will be this summation I square where I varies from 1 to n. I into j is basically 1 plus 2 plus 3 up to n into 1 plus 2 plus 3 up to n. We can simply write this as n minus 1 upon n minus 1 into, and this is this expression which is n plus 1 by 2 whole square minus this value which is n plus 1 2n plus 1 divided by 6. So here we can take n plus 1 by 2 common. So we can write n minus 1, n will cancel, it will be n minus 1, n plus 1, and we'll have n plus 1, we'll also have this 2 here, by 2 minus 2n plus 1 divided by 3, which we can also write as n minus 1 n plus 1 upon 12n minus 1, and here it will be 3n square minus n minus 2, and that's our third result. We can actually factorize this. So this is 3n square minus 3n plus 2n minus 2. So there will be 3n plus 2 into n minus 1. Now this n minus 1 and n minus 1 will cancel. So basically we can write this as n minus 1 n plus 1 into 3n plus 2 whole divided by 12. So now we have our 3 results. So this is our third result, which is this 2 times double summation exi xj. Then we have this exi square, and we have our ex. Now we can find this required variance, which is sum of numbers in first m tickets, and that will be ex square minus ex whole square. Now this ex square is basically second result plus third result, and this ex is first result. So now we can write this as ex square is n plus 1 to n plus 1 divided by 6 plus, now for this second result we have n minus 1 n plus 1 3n plus 2 whole divided by 12 and minus, and then ex is m into n plus 1 by 2 whole square. Now from this we can take m and n plus 1 common, and we can also take this 2 common, so we can write m into n plus 1 by 2 will be 2n plus 1 by 3. Here we'll have m minus 1 into 3n plus 2 by 6, and then we'll have m into n plus 1 divided by 2. Now we take this LCM, then we can write m into n plus 1 by 12, and here will be 4n plus 2 plus 3mn minus 3n plus 2m minus 2, and then here we'll have minus 3mn minus 3m. Now this 3mn will cancel, this plus 2 will also cancel, so here we'll have 4n minus 3n, n minus m, so there will be simply m into n plus 1 into n minus m whole divided by 12. So that's the required variance. Now once you have learned this, you'll be able to solve many more questions, such as find the variance of sum of k randomly drawn numbers from 1 to n, or in a box there are n balls numbered from 1 to n and we have selected m balls. We have to find variance of sum of numbers on these m balls. So all such questions, they'll be solved in the same way, and that's the answer to this question.